Hey guys, so here are questions, going to be 6 and 7 of your review. So here we go. Here we're going to be solving for cosecant. So we're going to start off by subtracting 5 from both sides. And we get 4 equals cosecant squared theta. So to get rid of the square, we have to take the square root. But remember, when you take the square root, you have to remember plus or minus 2. Okay, that plus or minus is going to be very important. Okay, so we have to get this in terms of sine or cosine. Okay, so I'm going to put this over 1. So the reciprocal of cosecant is sine theta equals plus or minus 1/2. Okay, so here we go. 1/2 equals sine theta. And we're going to need negative 1/2 equals sine theta. Okay, so for positive 1/2, it's going to be, hold on, 0. Okay, so it'll be pi over 6. And the other time it's going to be positive will be over at 5 pi over 6. Okay, and then this at negative, so when is it negative? So 7 pi over 6. And hold on. So I'm counting 1, 2, 7, 11 pi over 6. Okay, and remember, all the denominators should match. If they do not match, you might have made a mistake. Okay, so the next one. So negative 2 cotangent squared theta equals 1 minus 3 cotangent squared theta. Okay, here we're going to add 3 cotangent squared theta to both sides. Okay, when we do that, didn't draw a straight line there. So we get cotangent squared theta equals 1. And just like what we did before, we have to take the square root. So we're going to get cotangent theta is equal to plus or minus 1. Now we do want to get this in terms of tangent. So if I put this over 1, change this to tangent, and flip this, we get 1 over 1 still. So I need tangent theta equals 1 and tangent theta equals negative 1. Okay. Now, we're going to use the calculator. I'm not a huge fan of this, but tangent is just really difficult. So what you want to do is make sure your calculator is in degrees. Okay, so we'll sign up calc in degrees. Okay. And the way you separate tangent from theta, you're going to do inverse tangent. That would be your second and tangent. If you're in Desmos, go find function. Okay. Let me move my computer out the way. Okay. So when you type in inverse tangent of 1, you're actually going to get 45 degrees. But we want the answer in radians. So this is when you go on your unit circle, find 45, and you'll see that the answer is pi over 4. One nice thing about tangent, I'm going to draw a little sketch here because I don't have a unit circle. Here's pi over 4. You're going to go all the way to the other side. Okay, that's pi 3, 5 pi over 4. Okay, that is going to be also where the tangent is going to be the same. Okay, directly across. Okay, this only happens for tangent. Now, when you do the inverse tangent of negative 1, it gives you negative 45. And we don't have negative angles. So what you do is add 360, and it gives us 315. Okay, you go on your unit circle, and you're going to find it. It's going to be on here. and you get 7 pi over 4. Okay? And then you go across into quadrant 2, and you get 3 pi over 4. And that's the best way to handle tangent. Tangent is just a royal pain in the tush. Okay, let's see. I am so sorry. Next one, 6 equals 2 plus 2 secant theta. No matter how hard you want to do it, do not add these two. You cannot add these two. This one has secant on it, okay? So subtract 2, and we get 4 equals 2 secant theta. Divide by 2, and we get 2 is equal to secant. Okay, remember, I need this in terms of sine or cosine. So if I put this over 1, this will be 1/2 is equal to cosine theta. Okay, so then you go onto your unit circle and look for when is cosine equal to pi over 2. 1/2. And it happens at pi over 3. And then it's going to happen again at, let's see, give me 1 second. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 pi over 3. So this would be at 5 pi over 3. Okay. I don't have my unit circle with me, so I'm going old school. Okay. Can I do this one right here? Here is going to be 4 equal 2 plus 2 tangent. And again, we're going to have the same thing. Subtract 2 from both sides, and we get 2 equals 2 tangent theta. Divide by 2, and we get 1 equals tangent theta. We already did this one, and this is where we get pi over 4 and 5 pi over 4. But this is where you would do inverse tangent of 1, convert it into radians, and then go crisscross. Okay. Negative 2 plus 3 cosine theta equals 2 square root 2 minus 2 minus cosine theta. Okay, so I'm going to add 2 to both sides. What's nice, the 2's cancel. Let's see. Oh, nope. Hit the wrong button. I was trying to see if I can get it. That's as good as I get, isn't it? Okay, so we get 3 cosine theta is equal to 2 square root 2 minus cosine theta. I'm going to add cosine theta to both sides. And we get 4 cosine theta equal to 2 square root of 2. Divide by 4, and we can reduce this side. So this comes out to be cosine theta. I can take a 2 out the top and the bottom, and I get square root 2 over 2. Now, why does this one not have a plus or minus? Notice here we did start off with a square root in the problem, so we don't do plus or minus. So when does cosine equal square root 2 over 2? And we get pi over 4 and 7 pi over 4. Okay. Last one for this number. So we get 5 plus tangent theta equals negative 2 square root 3 plus 5 minus tangent theta. Okay. Subtract 5 from both sides, and we get tangent theta equals negative 2 square root 3 minus tangent theta. Add tangent to both sides. We get 2 tangent theta equals to negative 2 square root 3. And then we're going to divide by 2. So tangent theta equals negative square root 3. Okay. Again, we started off with the square root. I didn't put it in, so we don't do plus or minus. So just one last time. Inverse tangent of negative square root of 3, and that gets you negative 60. We need a positive answer, so add 360, and you get 300. So then that's when you look on the unit circle. Let's see. So you get 5 pi over 3. Okay, and then you're going to go across it, and you're going to get, I believe it is, hold on, 1, 2, 3, 4, 2 pi over 3. Okay, and that's how you get that one. Okay, last 2 questions. So now we're finally on number 7. And they tell us inverse tangent is square root 51. I'm sorry, inverse tangent. Look at me. It's tangent is equal to square root of 51 over 7. It tells us we're in quadrant 1. Remember, you will have a unit circle. You just find this, and this puts us in quadrant 1, and we want cosine 2 theta. Okay. AOH. Remember TOA, O over A, so square root of 51 and 7. I need my hypotenuse. So 7 squared plus the square root of 51 squared equals C squared. And you can type all of this in. Please put those parentheses in, and you get 100 square root, and we get 10. If you're thinking, why did I not do plus or minus? Remember, hypotenuse is always positive. So I need to find sine, which is O over H, so square root of 51 over 10, and cosine, which is 7 over 10. Okay, so I need this. Cosine 2 theta. So this is going to be, the formula is cosine squared theta minus sine squared theta. So 7 over 10 squared minus square root of 51 over 10 squared. Okay. So 7 squared is 49, 10 squared is 100, and then 51 over 100. We should always have common denominators. You get negative 2 over 100, which reduces to negative 1 over 50. And yes, you do have to reduce. Okay. And last but not least, sine is 4 over 5. We're in quadrant 1 again, but this time we want sine 2 theta. AOH. Sine is O over H. Hopefully by now, you'll notice it's a 3, 4, 5 triangle. Okay, I already have sine, so I need cosine, which is just 3 over 5. So here we go. They want sine 2 theta, and this is 2 sine theta cosine theta. Okay, I'm going to turn 2 into a fraction since everything else I'm going to deal with is a fraction. So sine is 4 over 5, and cosine is 3 over 5. And then all you have to do is multiply. 2 times 4 is 8, times 3 is 24. 1 times 5 is 25. Okay, also remember the top will always be smaller than the bottom. Okay, and that's it. So I wish you luck on your very last test of the semester. I know you'll be fabulous. Bye, guys.